Let's get into some of these graphs. You should be familiar with the parent functions. So the first thing we need to remember is amplitude and period, because these are the two things that go on the axes. Remember, you control the axes and you draw the graph the same. So the amplitude is, first of all, always positive, and it's the number in front of the word. The sign, and again, we're dealing with sine and cosine only. The sine period is 2 pi over b, and we want it to be positive, so drop all negative signs, so it's 2 pi over 4, and please reduce all fractions. For cosine, it's the exact same thing. The amplitude is the number out in front, and period is 2 pi over b. Now remember, b is the number in front of x, so this is just 2 pi. For here, the amplitude, again, remember your amplitude is always positive, so the amplitude is 5. Now the period, when you have a fraction, we have 2 pi over 1 divided by 1/3, which is the same thing as 2 pi over 1 times 3. So when you do, 2 pi over 1, I said it and wrote down the wrong thing. When you do this, you want to flip over the fraction and multiply. So straight across the top, straight across the bottom. So here the period is 6 pi. One more time. Again, sine and cosine, amplitude is always a positive number out in front, and the period is 2 pi divided by the fraction, which turns into 2 pi times the reciprocal. So this gives us 6 pi over 4, reduce all fractions, 3 pi over 2. Now I'm going to show you how we're going to do this with the amplitude and the period. So you will always be asked for those. You'll be asked for all the parts, but you will always be asked for period and amplitude because you always have that. So for here, it looks like we switched it. So period is 2 pi over b, which is a 1, and the amplitude is 2. So when you do this, you set up your axes. You go 1, 2, 3, 4, put the period here. Please mark halfway. The amplitude is 2, so it's up to you. Are you going to go 2 like that, or are you just going to make one mark and label it 2? It's up to you. Now we go to graph this. You just have to know the pattern. Sine is 0 in the beginning, middle, and end. Sine goes up to the amplitude and down, up first, so up between the first two zeros and down between the second two zeros. Connect your dots and you're done. Please make sure you draw all 5 dots. Period for this one is going to be 2 pi over 4, which is pi over 2. Amplitude, 3/2. So again, this is your choice. For your amplitude, you could go up 1 mark and call that 3/2 and down 1 mark and call that 3/2. Or you could make your graph feel more graph-like. 3/2 is 1.5, and you can just count by ones if you want to. Completely your choice. 1, 2, 3, 4. Here's where the period goes. Now, half of pi over 2 is really half of is multiply, so you're just multiplying. So we get pi over 4. So the halfway mark needs to be indicated, please. Now we're graphing cosine. And that's not, I don't think it's supposed to be negative. I think that's just a little dot on the paper. So it's positive. So cosine starts high, ends high, halfway it's low, and it has to go through the zeros in between. Again, please have all 5 dots and connect your graph. Remember, it is not pointy. It's very easy to draw the cosine like absolute value, but please don't do that because it's not absolute value. So for the period here, this is 2 pi divided by 8/3. So that's 2 pi times 3/8. So you can reduce that if you want to. I'm just going to multiply it. 6 pi over 8, so 3 pi over 4. The amplitude is 1. Now, we don't really have a place for this, but it does reflect. So you won't be asked about that. You just draw it. I'll show you how. 1, 2, 3, 4, period goes here. 3 pi over 4 times 1/2 is 3 pi over 8. Right, that's how you find half of something. Of means multiply. We're taking half. Now we still mark the amplitude, and when we graph this, it's different. So it's like a rotisserie. It's stuck to the midline. It's stuck to that axis, and then what happens is it just spins, so this high and the low switch places. So normally this sine would go up first, so normally we would be there, but because we have to reflect it, it's going to go down, which means the only place left to go is up. So that's what sine looks like when it reflects. And for cosine when it reflects, here the period, now that we're kind of good at this, super good shortcut, just flip it over. You know you're going to eventually. You know you're going to flip that fraction. So flip the one that comes out of the equation, just flip it over. And then we get, looks like 3 pi. The amplitude here is 5/2, which is 2.5. Or you can just mark one mark, call it 5/2. 1, 2, 3. I'm going to go and indicate and try to graph this sort of a little bit more accurately. And then we do 1, 2, 3, 4, 3 pi, and then half of that's pretty easy. It's just 3 pi over 2. Don't worry about making it a decimal. Decimal and pi doesn't really go together anyway. So we do have to reflect it. So normally cosine would start high. Right, so normally it would start high and end high, but we want to reflect this over the x-axis or the theta axis. So now it's going to start low and end low, which means on the halfway mark it's going to be high, but the zeros stay where they always have been. Now let's do some tangent. Quick reminder, period is 1 pi over b, and it's really absolute value because we always want it to be positive. The amplitude is there isn't one. No matter what there is out there, it's undefined. So if you notice, you're not even asked for it. So I'm not trying to fool you and make this think that you're supposed to write that down, but that's not to say you won't be asked for it. So sometimes when we put them all together, the questions are all the same. So you have to remember to write undefined, not possible, not there, NA, something that you indicate that you know that there isn't one. Please don't write 0. 0 is a value, and we don't want to do 0. So you could write none, example. So for here, the period is pi over b. So be careful with that. This is real easy to do wrong. B is 1, so it's just pi over 1. So the period is 1. 1 pi. Now we go to graph this. It's tangent, so you got to give some space to the left. You're going to double this when you put it on the graph. 1, 2, 3, 4, double it. Move it backwards, 2 marks. You got 2 marks forward is pi, so 2 marks backwards is negative pi. So now we're going to have asymptotes. Now the pattern is, and this is just, maybe just memorize it, the pattern is 1 mark to the left is an asymptote. Then it just goes in order. Asymptote, 0. Asymptote, 0. Asymptote. Now you can kind of know you're doing it right because you have this little guy out here that doesn't really have anything, and you have this little guy out here that doesn't really have anything, doesn't have any marks on it at all. Then you just draw it in. It starts up high on the right, crosses over, and ends up low on the left. Done. Now we do have a reflection here. So you just have to pay attention to it. It's a little bit weird. So there's, like I said, there's no real place that you have to indicate that. You just do it on the graph. So the period is going to be pi divided by 1/2, which is really pi over 1 times 2. So our period is 2 pi. If you notice in that first graph, I didn't even mark that y-axis. You can do the same thing. 1, 2, 3, 4, double the period. Now halfway. 2 the other way, you know what it is, because you have 2 to the right, so 2 to the left is just negative of that. So we skip the first one. We know it starts 1 space to the left, asymptote rather, 0, asymptote, 0, asymptote. Draw it in. It does have arrows on the ends. Please make sure you do that. Sine and cosine, you don't have to have the arrows because sometimes it's confusing. It makes it look like it goes up instead of bends. But you got to realize that the domain the range rather goes up to infinity and down to a negative infinity. That's kind of a big deal for tangent. All right, now last one. Amplitude is not asked for. Tangent has a period, so we have, sorry, I'm thinking out loud, pi over b. Oh, well, this one's easy. Just pi over 2. Make sure you have space to the left. 1, 2, 3, 4. Double that, that's pi. Half of that, pi over 2. 2 marks to the left, negative pi over 2. 1 spot to the left, asymptote. 0, asymptote. 0, asymptote. Draw it in. So again, we control the axes, which is why you won't ever have any graph paper, and then the graphs look the same. Oh, I didn't reflect this one. I knew that's what I was like. There's something weird about this. And that happens a lot. Let me fix this. You probably already know that. I just didn't, I don't know, I wrote it and then I never did it. So this graph is not really this. Let's fix it here. So we know the asymptotes and the zeros. Oops. I'm graphing cotangent here. So let's do this again. We know that the asymptote is 1 mark back, 0, asymptote, 0, asymptote. When you reflect this one, let's do it right this time, starts high on the left and crosses over. So I'm sorry that I graphed that incorrectly, but I'm glad I caught it. So this is the wrong one. So try them out for yourself. If you can't get it, just stop and bring it into class, and we'll get it all fixed up for you.